One last example here. We've got a block with mass 1.1 kilograms. It's pushed up an inclined plane that is angled at 19 degrees above the horizontal. Coefficient of kinetic friction between the block and the plane is 0.21. Pushing force is applied parallel to the plane, and the block accelerates at a rate of 1.3 meters per second squared. And the question is, what is the magnitude of the pushing force? As always, let's draw a picture. We've got our plane, we've got our block. We've got an angle of 19 degrees. And let's draw in our forces. We have gravitational force acting on the block. We have a pushing force going up the ramp. We have a normal force perpendicular to the ramp. And because the block is moving up the ramp, it's being pushed up the incline. The block is being pushed up the incline, which means that the frictional force, which always opposes motion, will be pointing down the ramp in this case. Kinetic friction is pointing down the ramp. As usual, we rotate our coordinate system. And now we can start writing our Newton's second law equations. Sum of our forces in the y direction is going to be 0 because the block stays on the ramp. Normal force minus mg cosine theta. So our normal force is equal to mg cosine theta. This will often be the case in inclined plane, but again, it's not a set rule. If this pushing force was angled, then if the pushing force wasn't parallel to the ramp, then that would show up in this part of the equation as well. In the x direction, one of the forces in the x direction is equal to mass times acceleration. We have mg sine theta and kinetic friction going down the ramp. And then we have the pushing force going up the ramp. Sorry, I broke the lines there. So, in the x direction, we have ma equals mg sine theta. Kinetic friction is mu k times normal force, which in this case is mg cosine theta, mu k times normal force, which is mg cos theta, minus the pushing force. So if we rearrange, that pushing force is equal to mg sine theta plus mu k mg cosine theta minus ma. From there, we can plug in numbers. Our mass is 1.1 kilograms. G is G sine 19 plus 0.21 times 1.1 times 9.8 cosine 19 minus mass 1.1 times acceleration 1.3. And we can punch all those shenanigans into the calculator. Got 1.1 times 9.8 sine 19 plus 0.21 times 1.1 times 9.8 cosine 19 minus 1.1 times 1.3, and the calculator will spit out that the pushing force has a magnitude of 4.22 newtons, about. That's about as complicated as your problems are going to get, at least outside of an extra credit problem. So you can see that once we add friction to the mix, we start getting much more complex sorts of scenarios.